Okay, this lesson is all about simplifying these rational expressions, fractions of polynomials, and stating the excluded values, the restricted values, the illegal values, if you will. Now, as far as finding the restricted values, there are, it's really one thing that you have to do. You set the denominator equal to 0, and you solve. Or I should say, set the denominator not equal to 0. You should put your pencil down if you're watching this video, and watch and learn, but then go back and try to do this problem by yourself on your own. And then see if you can do the next problem by yourself in the first place. But don't copy along with me because you won't learn anything that way. So, finding the restricted values. The denominator cannot equal 0, so that means x plus 8 cannot equal 0. If I subtract 8 from both sides, that tells me that x cannot equal negative 8. Okay, so that is my restricted value. Now, as far as simplifying, let's see if anything will factor. Okay, if I can factor this, then there you go. I see a GCF in the numerator, so I've got 4, and then this would be x plus 8. Okay, in the denominator, I still have this x plus 8. Okay, well, you can see the x plus 8s are the same. So they will cancel out because they are the same factor. All right, so the simplified version of this is simply 4. Okay, 4. So just put this all together into one answer, and then there you go. All right, so this is the simplified answer with the excluded values. Let's take a look at number 2. All right, again, I can get the excluded values by noticing that the denominator cannot equal 0. Subtracting 5 from both sides means that m cannot be negative 5. So that is my excluded value right there. Okay, now let me see if I can factor the numerator or not. So if I try to factor the numerator, there's no common factor, so my only hope is binomial times binomial. M squared is m times m. 15 could either be 3 times 5 or 1 times 15. I'm betting on 3 times 5. Okay, and look, everything is positive, so that would be positive and positive. And yes, inner, I have 3m. Outer, I have 5m. And together that makes 8, so that looks good. So this is how it factors. Now the denominator is m plus 5, which is the same thing I had in the top. So the simplified version is m plus 3. Okay, so there's the simplified answer and the restrictions. All right, looking at number 3. For the restrictions, I know the denominator cannot equal 0. All right, so subtracting 3 from both sides, this tells me that negative n cannot equal negative 3. Now, dividing both sides by negative 1 tells me that n cannot equal positive 3. Okay, so this is my restricted value. Okay, now I'm going to go back and find the simplified version of this problem. Okay, so I'm going to factor now. If I factor, that's going to be 5 times n minus 3. 5 times 3 is 15, so it makes sense. Okay, you know what? It's time to talk about something. I've been meaning to talk to you about something. All right, see how this is backwards? Let's talk about how to fix things that are backwards. Let's have a side lesson. All right, meet me in the dark room. Okay, let's have a dark room lesson on backwards binomials, let's say. So for example, say if I have 2 minus n. Okay, we know this is backwards. Now, if I switch this around though, I have to be very careful. Right? This 2 minus n is sort of like this. It's like I've got a 2 and I've got a negative n. Okay, and in fact, you could think of this as a positive 2 and a negative n. So when we go to switch this around and write it in the proper order, the negative goes with the n. So I will have negative n and then plus 2. Okay, but when we're talking about factoring and canceling and such, we really don't want the leading coefficient to be negative like this. So what we do is we treat this like a negative 1, and we factor out that negative 1. So if I factor out the negative 1, meaning put it outside of parentheses, then guess what? Negative 1 times n would be negative 1n. Negative 1 times negative 2 will be positive 2. Okay? So in the end, we don't really want to put the 1 there. Okay? So in the final analysis, what we have is 2 minus n is the same thing as negative n minus 2. Okay? Now, I don't want to have to go through that process every time. So this little side lesson is to teach you this pattern so we can just do it immediately. 2 minus n is equal to negative n minus 2. Okay? So in other words, just reversing, you can just swap the 2 and the n without worrying about the sign, as long as you realize it'll be the opposite. So put a negative sign out front. Okay, let's practice that skill with other variables. Okay, so let's say if I had 5 minus p, what would that be equal to? Negative p minus 5. Okay, what if I had 7 minus x? What would that be equal to? That would be negative quantity x minus 7. Do you see the pattern? What if I had x minus y, and just for some reason, just do it. That would be the same thing as negative y minus x. Okay? So that pattern is worth memorizing. So you can just immediately, oh, okay, what? It's backwards? Write it forwards and put a negative outside the parentheses. Okay, why am I mentioning that now? Well, you tell me. 3 minus n, use the skill I just taught you. What am I going to put? I'm going to put negative and then just n minus 3. Okay, so now it's easy to see that these will in fact cancel. Okay, but I got this negative sign down here floating around. Well, it's like a negative 1. So it's like I have 5 divided by negative 1. So that's just going to be negative 5. All right, so the simplified answer is negative 5. The restricted value is n cannot be 3. Okay. Hope we get to use that skill again at some point in this lesson. Got to reinforce it. All right, how about this one? So once again, let's find the restricted value. The denominator cannot equal 0. So if I subtract 70 from both sides, I get that 70a cannot equal negative 70. Time to divide both sides by 70. Okay, so that is going to give me that a cannot equal negative 1. So that is my restricted value. A cannot equal negative 1. Now let's go back and factor. Okay, factor mode. So I've got 40 over 70 factors out. So that's going to be a plus 1, right? Because 70 times a is 70a. 70 times 1 is 70. Distributive property. Now, this will reduce, though, okay? Both of these are divisible by 10. So if I divide by 10, I should use a different color, shouldn't I? I could divide both of these by 10. Okay, if I do that, then I'm going to get, all right, 40 divided by, that's 4 over 7. And I've still got this a plus 1 going on. Okay, so I could write this as my answer, right? I could have 4 over 7 times a plus 1. Okay? So here's my simplified answer and my restricted value or excluded value. Now I could have distributed this and I could have written 4 and then 7a plus 7. Okay, that's the same thing. So either way. Okay, here again, number 5. If I want to know the restricted values, I will set the denominator not equal to 0 because you can't have that. So in this case, that means that 40n is not equal to 0. If I divide both sides by 40, then I discover that n cannot equal 0. So that is my restricted value. Alright, now for the simplified version, I need to factor. So let's see. 12 does not go into 28. How about, I know 4 goes into 28. Let's do 4. see if that's enough. So the GCF here, I think, is 4n. But I'll see once I see what's left. All right. So that's going to leave 3n, well, 3n plus 7. All right, and there's no more GCF, so I did the right thing. And that is over 40n. I'm putting it over here on the left because I know I'm about to cancel some stuff out. So I know that these n's will cancel out. All right, this is connected by multiplication, so it's okay. All right, so the n's cancel out. Now the 1 and the 4 and the 40, these are both divisible by 4. So that's what I'm doing. I'm dividing these both by 4. Okay, if I do that, then 4 divided by 4 is 1. Okay, the n's are gone now. 40 divided by 4 is 10. Okay, so I really don't need the 1 in the front though. So I'm just going to have 3n plus 7 over 10. So this is the simplified version. And this is the excluded value. So that's number 5. How about number 6? All right, I see some factorization in our future here. All right, so in the denominator, a squared is a times a. All right, 70. There are other things that can happen, but it's definitely 7 times 10, right, which looks promising because of the 17. You know how we always say inner plus outer has to give you the middle? Well, 7 plus 10 does make 17. So all I need is for everything to be positive, and I am a winner. And positive 7 times positive 10 is positive 70. So that is how you factor the denominator. How about the numerator? All right, see how everything is positive? Okay, if everything is positive, that means it's got to be plus and plus. All right, it's no other way. So looking at the 21, first thing that pops into my head is 3 times 7. 3 times 7 is 21. And, you know, inner plus outer equals middle. It's 3a plus 7a does make 10a, so we're good. So this is how you factor it. Now, let's talk about the restricted values. The denominator cannot equal 0. That means neither one of these factors can equal 0. A plus 7 cannot equal 0. A plus 10 cannot equal 0. Subtracting 7 from both sides tells me that a cannot equal negative 7. Okay, subtracting 10 from both sides tells me that a cannot equal negative 10. So these are my restricted values. Okay, now let's talk about the simplified form of this. Well, all that's left to do is cancel out the a plus 7s, which are the same factor. And that is going to leave a plus 3 over a plus 10. So I've got a plus 3 over a plus 10. And that is the final answer. Please do not think you can cancel out these a's, okay? When things are connected by addition or subtraction, you can't cancel them out, okay? That doesn't make any sense. So that's it, a plus 3 over a plus 10. And these are the restricted values, the excluded values. Let us factor. 9 is the GCF here, so that'll be 9 times r plus 5. Here the GCF is 3r, and that's going to leave behind r plus 5. Now, as far as the restricted values, please understand that only r plus 5 has to be worried about, okay? R plus 5 cannot equal 0. All right, 9 is already not 0, so I don't have to worry about that. If 9 times something is in the denominator, the only thing we have to worry about is making sure that r plus 5 is not 0. 9 is not going to turn into a 0, so ignore that. Meanwhile, over here, subtracting 5 from both sides, r cannot be negative 5. So that is my restricted value, just one restriction. Okay, now as far as the simplified form, just cross out these r plus 5s, and we need to reduce these as well. Right, both of these are divisible by 3. So you got to do it. Okay, 3 divided by 3 is 1. So that's like 1r over, and 9 divided by 3 is 3. So it's like 1r over 3, but do we really need the 1? No. So it's really just r over 3. So there it is, r over 3, r cannot equal negative 5. By the way, do you have a pen or a pencil in your hand? Well, if you do, put it down. Shame on you. Don't I talk to you about this every day? If you just copy off of me, you're not going to learn anything. All right? Put the pencil down. Try to do the problem by yourself first. If you're still getting it wrong, watch the video and learn how to do it, but then go back and do it by yourself. Factoring the denominator, I'm thinking r plus 4 times r plus 10, right? 4 times 10 is 40, okay, and that gives us inner 4r, outer 10r. Well, that makes 14, so that's why I like that. Okay, r squared in the numerator here, r squared is r times r. Now 50, okay, is 5 times 10. Okay, so I'm going to need a positive 10 and a negative 5 to make a positive 5r. Okay, so as far as the restrictions, both of these are going to give me an excluded value. Okay, because r plus 4 cannot equal 0, and r plus 10 cannot equal 0. Subtracting 4 from both sides, r cannot equal negative 4. Subtracting 10 from both sides, r cannot equal negative 10. So those are the restricted values. Once I cancel out the r plus 10s, that's going to leave me with r minus 5 over r plus 4. Okay, that's it for number 8. All right, we are down to the last couple problems, which is good because I'm starting to lose my voice. This is the difference of two squares. So this is going to factor as k plus 3 times k minus 3. Okay, meanwhile, the numerator has a GCF, a common factor of 7k. Okay, that's going to leave behind k minus 3. Both of these factors will give me a restricted value because k plus 3 cannot equal 0 and k minus 3 cannot equal 0. Subtracting 3 from both sides gives me k cannot equal negative 3. Adding 3 to both sides gives me k cannot equal positive 3. So these are my restrictions. Okay, that's it. Now as far as the simplified version, the k plus 3's cancel out. So that's going to leave me with 7k over k minus 3. All right, notice that you cannot cancel out these k's because this is connected by subtraction. All right, if this were 3k, instead I could cancel them. So that's number 9. All right, this is the last problem. Okay, let's factor. X squared is x times x. 24. It could be 6 times 4 or 4 times 6. Oh, well, that's the same thing. It could be, all right, it could be 4 times 6 or 2 times 12 or 1 times 24. Oh, I left out the 3, or 3 times 8. I knew I was missing something. Anyway, based on the 10, I'm betting on, well, it could be, either one of these could make a 10. Okay, let's try the 4 and 6 first. If I do the 4 and 6, because I'm thinking, oh, look, there's a 10. Inner plus outer has to give me the middle. Inner, I have 4x. Outer, I have 6x. If I want to get a negative 10, both of these have to be negative. So that would make these both negative. Will that give me a positive 24? Yes, because a negative times a negative is a positive. So that's how you factor it. You erase all this stuff now. Okay, now the numerator. Okay, x squared is clearly x times x. When I look at 48, the first thing that pops into my head is 6 times 8 is 48. Okay, and inner I have 6x. outer, I have 8x. Let's see, is there a way I can get negative 14 if I pick the signs right? You bet your sweet bippy. If they're both negative, that makes negative 14. That means these would both be negative. Will that give me a positive 48? Sure, negative times negative is a positive. So this is factored correctly. Now, the denominator here will give us the restricted values. We'll have two of them. X minus 4 cannot equal 0. And x minus 6 cannot equal 0. Adding 4 to both sides gives me that x cannot be 4. Adding 6 to both sides gives me that x cannot be 6. So these are my excluded values, restrictions. Now, as far as the simplified form, the x minus 6's will cancel out. So that leaves x minus 8 over x minus 4. And that's it. And that is it for our lesson today. All right, I hope this was a helpful lesson for you. And I hope you didn't copy off of me the whole time. I hope you make sure you can do every problem by yourself. I'll see you on the next video.